Did you know that over 70% of software projects fail? Not because of bad code, but because of bad planning? That means billions of dollars wasted every single year, not on bugs, but on building the wrong thing entirely. If you've ever wondered how tech teams actually figure out what to build and how to build it, this video is for you. Today we're breaking down one of the most important processes in the tech world: systems analysis, design, and development. By the end of this video, you'll understand the full journey of how an information system goes from a vague idea to a working solution that real people actually use. We'll cover the systems development lifecycle, how analysts gather requirements, how systems get designed from the ground up, different development approaches, and why testing and maintenance matter more than most people think. Let's get into it. Section 1. The Systems Development Lifecycle. Think of the Systems Development Lifecycle, or SDLC for short, as the master blueprint for every software or information system ever built. It's a structured process that guides teams through every phase of creating a system, from the first spark of an idea all the way to the moment it goes live and beyond. The SDLC typically includes 5 core phases: planning, analysis, design, implementation, and maintenance. Each phase has a specific purpose, and skipping any one of them is like trying to build a house without a foundation. In the planning phase, the team figures out whether a project is even worth doing. Is there a real problem here? Do we have the resources to solve it? What's the return on investment? Then comes analysis, where teams dig deep into understanding what the system actually needs to do. After that, design turns those needs into a detailed blueprint. Implementation is where the actual building happens: coding, configuring, testing. And finally, maintenance keeps the system healthy and updated long after launch. Here's the fascinating part: these phases aren't always linear. Different organizations use different variations of this cycle, and some loop back constantly. So how do teams decide which approach to take? That's exactly what we're exploring next. Section 2. Requirements Gathering and Analysis. This is where most failed projects go wrong. Requirements gathering sounds simple. Just ask people what they want, right? But anyone who's worked in tech will tell you it's one of the hardest things in the entire process. Users often can't fully articulate what they need. They describe symptoms, not root causes. They say things like, "The system is slow," or "It's hard to use." But translating those complaints into specific, buildable features requires serious skill. Systems analysts use a variety of techniques to uncover real requirements. Interviews are the most direct, sitting down with stakeholders and asking targeted questions. Surveys allow teams to gather input from large groups quickly. Observation involves watching users actually do their work to spot inefficiencies they might not even notice themselves. Another powerful tool is the use case. A use case describes a specific interaction between a user and the system, like user submits a purchase order, or admin generates a monthly report. These simple narratives help teams stay focused on real-world behavior, instead of abstract features. Once requirements are collected, they get documented in something called a requirement specification. This document becomes the contract between what the client wants and what the development team will build. And here's a question worth sitting with. What happens when stakeholders change their minds midway through the project? That tension between changing requirements and fixed timelines is exactly what led to the development of entirely new methodologies. We'll get to that. But first, design. Section 3. System Design. If analysis asks, what should the system do, design asks, how should it do it? This phase is about turning requirements into a concrete blueprint that developers can actually build from. System design operates on 2 levels. Logical design describes what the system will do in functional terms: data flows, processes, inputs, and outputs, without worrying about specific technology. Physical design then translates that logic into actual hardware, software, databases, and interfaces. One of the most important tools in system design is data modeling. Data models define what information the system will store, and how different pieces of data relate to each other. You've probably heard of databases. Data modeling is what makes a database actually useful and organized. Process modeling is equally important. Flowcharts and data flow diagrams help teams visualize how information moves through the system step by step. User interface design is another critical component. A system can work perfectly on the back end and still fail completely because users find it confusing or frustrating. Good UI design puts the user's experience at the center of every decision. Great design isn't just technical, it's almost creative. And that leads to an interesting question. Once you have a design, what's the best way to actually build it? The answer depends a lot on which development approach you choose. Section 4. Development approaches. Not every project gets built the same way. Over the decades, the tech industry has experimented with different methodologies, each with its own strengths and trade-offs. The oldest and most structured is the waterfall model. It follows the SDLC phases in strict sequential order. You finish one phase completely before starting the next. It's predictable and well documented, but it's also rigid. If requirements change halfway through, going back is expensive and painful. That rigidity gave rise to Agile development. Agile breaks projects into short cycles called sprints, usually 2 to 4 weeks, where small pieces of the system get built, tested, and delivered continuously. Teams stay flexible, adapt to feedback quickly, and keep stakeholders involved throughout. Agile has become the dominant methodology in modern software development for good reason. It accepts change as normal rather than treating it as a failure. There's also the prototyping approach, where teams build a rough early version of the system, a prototype, specifically to get user feedback before committing to full development. This is especially useful when requirements are unclear from the start. Spiral development combines elements of both waterfall and prototyping, emphasizing risk analysis at every stage. It's commonly used in large, complex projects where the stakes are especially high. Each methodology reflects a different philosophy about uncertainty, collaboration, and control. Choosing the right one can make or break a project. But even with the perfect methodology, there's one final phase that separates good systems from truly reliable ones. Section 5. Testing, implementation, and maintenance. Building a system is only half the job. Making sure it actually works and keeps working is where long-term success is won or lost. Testing is not just checking for bugs. It's a systematic process with multiple layers. Unit testing checks individual components in isolation. Integration testing verifies that different parts work together correctly. System testing evaluates the entire system as a whole. And user acceptance testing, or UAT, puts the system in front of real users to confirm it meets their actual needs. Implementation is the moment the system goes live. Teams have to plan this carefully. A direct cutover switches from the old system to the new one instantly. High risk, but simple. Parallel running keeps both systems running simultaneously until confidence builds. Phased implementation rolls out the system gradually, one module or location at a time. And then there's maintenance. This is the phase that never really ends. Systems need updates, security patches, performance improvements, and adaptations as business needs evolve. Studies show that maintenance can consume up to 70% of a system's total lifetime cost, which is why building for maintainability from day one matters so much. Every great system you use today, from your banking app to your school's registration portal, went through every one of these phases. The invisible work behind the scenes is what makes the visible experience feel effortless. So there you have it. The full journey of systems analysis, design, and development, from the SDLC framework to gathering requirements, designing the blueprint, choosing a development methodology, and finally testing and maintaining the finished product. If this gave you a clearer picture of how technology actually gets built, hit that like button. It genuinely helps this channel reach more people who want to learn this stuff. Subscribe if you want more breakdowns of information systems, technology, and how the digital world actually works. And drop a comment below. Which phase do you think is the most underrated? Is it requirements gathering, testing, maintenance? I'd love to hear what you think. See you in the next one.